Okay, so the car has, oh, this one, we ignore that one. There's some information missing, so that's just a no for that one. Car has a mass of 1,300 kilograms. Calculate the kinetic energy of the car in joules when it is traveling at a velocity of 20 meters per second. Right, we're going to do the same thing. We're going to write down our equation. EK equals 1/2 times m times v squared. Put in our substituted numbers, 1/2 times 1,300 times 20 squared. It is so important to remember that squared because so many people forget it. And there are no benefit of doubt marks if you do that because you substituted into the wrong equation. Kinetic energy here, 260,000 joules. Next one then, a man pulls a suitcase with a horizontal force F as shown in figure 10. There it is. Two of the forces acting in the suitcase are labeled P and Q. The man pulls a suitcase for 80 meters along a horizontal path. Distance equals 80 meters. The mass of the man in the suitcase is 85 kilograms. The man does 1,200 joules of work on the suitcase as he pulls the suitcase along. He walks with an average velocity of 1.5 meters per second. Calculate the kinetic energy. EK is equal to 1/2 times m times v squared. Do we have everything that we need? Yes, we have velocity. Yes, we have mass. EK is therefore equal to 1/2 times 85 times 1.5 squared. 0.5 times 85 times 1.5 squared. You know, I nearly didn't square that. I nearly didn't, but I did. 95.625. Calculate the horizontal force F that the man exerts on the case. Okay, well, where are my numbers? There are no numbers here. Haha, yes, there are. They are up here. If you look over at the sheet, we have got an equation that says that the amount of energy transferred or the work done is equal to the force times the distance. So we need to find the work done to be 1,200 joules and the distance traveled 80 meters. I'm going to use the equation E equals F times D. Rearrange that. F equals E divided by D. F is equal to 1,200 divided by 80. 1,200 divided by 80, give me an answer of 15 newtons. Next, the volume of 380 grams of ice, so the mass is equal to 380 grams, and the volume is 410 centimeters cubed. Calculate the density equals I don't know how many grams per centimeter cubed. Now, normally we like to go down to kilograms or to meters cubed, but look here, the units are asking you for grams per centimeters cubed. So check those units before you start. Check yourself before you wreck yourself, as cool people say. Density is mass divided by volume. Density is therefore 380 divided by 410. 110, and that gives us the answer of 0.9268. 0.9268, 0.93, good enough. Another student decides to melt some ice. Good for them. The student melts 380 grams of ice, 380 grams of ice at 0 degrees Celsius. That is a temperature, so I'll put in theta there for 0 degrees Celsius. The specific latent heat of fusion of ice, and that is L, is equal to 3.34 times 10 to the 5 joules per kilogram. Calculate the thermal energy needed to melt the ice. Now, we see 380 grams here. Up here, it was okay because the unit wanted it in grams, but I'm going to have to divide that by 100 to make 0.38 kilograms for this particular one, because the kilograms is given in the units. The kilograms is what we need to supply. The equation is Q is equal to M times L, specific latent heat of fusion, is equal to the mass times latent heat. So just write down Q is equal to 0.38 times 3.34 times 10 to the 5. This is 0.38 times 3.34 times 10 to the power of 5. 126,920 joules. Repairing a bicycle. Repairing, I read that as, but it's not repairing. A cyclist is riding a bicycle at a steady velocity of 12 meters per second. The cyclist and the bicycle have a total mass of 68 kilograms. I wonder where this is going. Kinetic energy is what they're asking us to make. EK is equal to 1/2 times mass times velocity squared. EK is equal to 1/2 times 68 times 12 squared. 0.5 times 68 times 144. I hope you're impressed I did that in my head. 4896 joules. A lamp is connected to a potential difference, a voltage of 0.24 volts. Current in the lamp is 0.12 amps. I is equal to 0.12 amps. Calculate the power of the lamp. P is equal to, I do not know, in watts. Look at my equation. I'm going to see that P is equal to I times V. Power is current times voltage. Power is equal to 0.12 times 0.24. Excuse me. And my answer is 0.0288 watts. That looks like a 9, so I'm going to cancel that. 0.0288. Okay. Like I said, I'm drawing with the mouse, so you got to give me credit for that one. Potential difference is changed to 0.3 volts. Voltage is 0.30 V. The current in the lamp is now 0.13 amps. The lamp is switched on for 35 seconds. Calculate the energy that is transferred in this time. This is the equation. Energy is equal to voltage times current times time that the equation is on. So E is equal to V times I times T. It's looking for energy transferred. I don't have to do anything funny. There's no prefixes there. So I can just do my 0.3 times 0.13 times 35. Sometimes I'll give this in minutes and you've got to change over to seconds, but they're not doing that to us right now because they're decent human beings. 1.365. And I'm going to put that down to 1.37 because I've got 2 decimal points there, 1 decimal point there, so I'll give it back in 2 decimal points. The current of the lamp stays at 0.13 amps. Calculate the charge that flows through the lamp in 35 seconds. The time they gave us was 35 seconds. We've got 0.3 amps. They want the charge. And it's not just the charge, is it? We call it the quantity of charge, which is why the symbol for charge is Q. Q is equal to I times T. Now I'm just getting ahead of myself. Take a big deep breath because you're getting far too excited. Q is equal to I times T. Q is equal to 0.13 times 35. 0.13 times 35. Ooh, I just said 5 there in my calculator. But I could just blame somebody else for that, I suppose. Because no one can see me doing it. Master criminal, Mr. McKelvey. Charge 4.55 coulombs. Going to leave it like that. 2 decimal points there, 2 decimal points there. Everything's happy. The electromagnetic spectrum is continuous, and that just means that there's no difference in the makeup of the waves, but there is a difference between subtly changing. There is a subtly changing difference between different parts of the spectrum. Different regions of the spectrum have different properties. An electromagnetic wave has a frequency of F is equal to 7 times 10 to the 9. I'm glad we're getting one of these. And the velocity of the wave is 3 times 10 to the 8. Calculate the wavelength of the wave. Now, velocity is equal to frequency times wavelength. Wavelength is therefore equal to velocity divided by frequency. And I'm going to press A over B in my calculator. I'm going to put my frequency number in, 7 times 10 to the power of 9. I'm going to press down on my directional buttons until I realize I've made a mistake because I put the wrong number in at the top just as well. I did all my working out properly because wavelength is equal to velocity divided by frequency, not the other way around. 3 times 10 to the power of 8. Well done, any of you that spotted that. In fact, if there's any of you listening to this, and you can roast me about it, so that roast is a colloquial term, I believe, for making somebody feel silly about themselves. But yeah, you can roast me. 0.043 or 0.04 meters, entirely up to you. Yeah, you can tell me that I made a mistake there, and then I'll know that you watched it, which would be very impressive. He is investigating to see if the padding stops the egg from breaking. Don't know anything about this context, but I don't need it because the weight of the egg, weight is equal to 0.6 newtons. Calculate the work done on the egg to lift it up by 20 meters. The height is equal to 20 meters. But remember, an upwards height is just a sidewards distance, but in an upwards direction. So I could also write that down as distance is equal to that. And another word for weight, of course, is force, because weight is the force due to gravity acting down on an object. So what I really have here is the force and the distance. And they're asking me to calculate the work done, which, as we all know, is energy in I don't know how many bits of energy, but they're measured in joules. My equation, E is equal to F times D. And E is equal to 0.6 times 20. We can do this in our heads, but I'm still going to use my calculator. Work done is equal to 12 joules. Light and sound waves are produced at the same time by an explosion on Earth. Oh no! Whoops! The sound of the explosion is heard 1,920 meters away in 6 seconds after the explosion. Calculate the speed of sound in air in meters per second. Speed is equal to distance divided by time. It's given as a distance, 1920 divided by 6. Speed is equal to 1920 divided by 6. That's 320 meters per second. Battery sends a current through a metal wire. Current is equal to 3.7 amps. Calculate the charge. It's asking me for the quantity of charge in coulombs that flows into the wire in 13 seconds. Nothing funny going on here, no units or anything like that. Q is equal to Y. Well, there are units, but there are no prefixes to those units. Q is equal to Y times T. Q is equal to 3.7 times 13. 3.7 times 13 is equal to 48.1. Q is equal to 48.1 coulombs of charge. The students use a telescope to view the moon. Light from the moon takes 1.3 seconds to reach the students. T is equal to 1.3 seconds. The speed of light is 300,000 kilometers per second. Speed is equal to 300,000 kilometers per second. Calculate the distance to the moon. Now, in the actual GCSE, you'd have a lot more room here, but something just got squidged out for whatever reason. Now, this is 300,000 kilometers per second. Look at the units. It's asking for us in meters, so I'm going to times that by 1,000 to give me 300 million meters a second. Distance equals speed times time. I don't need to rewrite the equation because it's already written there for me. So I'll do 300 million multiplied by 1.3. 390 million meters. Golly, that's a long way. Photograph shows a man dropping an egg inside a padded box from a height. The weight of the egg is 0.6 newtons. Now, wait a second. I'm going to take a break here because I feel like changing my pen color. Let's do orange. It'd be risky. The weight of the egg is 0.6 newtons. Calculate the work done against the egg to lift it 20 meters. State the unit. Again, this is weight, but weight is a type of a force. And even though it says to lift it up, remember that height is just a distance that's upwards. It's asking me for the work energy done, so I don't know how many joules. We'll say that energy is equal to force multiplied by distance, because weight is a force, and distance is just a height on its side. E is equal to 0.6 times 20 meters. Now, this time, you get 1 mark for the answer, or probably 2 marks, pardon me, for the answer, and 1 mark for saying the correct unit for work done, which is, of course, joules. And I'm just double checking because I'm just pointing. 20. Yeah, okay. The diagram shows an electric circuit with 2 resistors, R and S. R has a resistance of 11 ohms. Now, in these ones, I like to annotate my diagrams. Calculate the potential difference across R. So it's asking me to find voltage. Now, I've got my resistance, which equals 11 ohms. I've got a current that's going through R of 0.4 amps. It's asking me to calculate the potential difference, or the volt in volts. V is equal to I times R. V is equal to 11 times 0.4. Well, it's the other way around. It's R times I. I've just written it there. But I like the number 11. It pleases me. Potential difference is 4.4 volts. The resistance of the heater, R, is equal to 15 ohms. The current in the heater, I, is 0.56 amps. Calculate the potential difference voltage across the heater. They even gave us voltage there, which is nice to them. V is equal to I times R. V is equal to 0.56 times 15. I don't like 15. It's an obnoxious number. Got a green hint about it. Voltage is equal to 8.4 volts. The technician changes the value of the variable resistor. She measures the new voltage across the heater and the new current in it. Here are her results. The voltage is equal to 6.0 volts and the current is equal to 0.4 amps. Calculate the amount of electrical energy transferred in 30 seconds by the heater. 30 seconds. And we're looking for electrical energy, so we will, of course, be looking for E measured in joules. The equation we want is E is equal to V times. I'm just moving this around. E is equal to V times I. And we're going to substitute our numbers in. It'll be 6 times 0.4 times 30. 6 times 0.4 times 30 equals 192 joules. And I'm looking, there's nothing extra, there's nothing weird. Checking my answer, all is well. Torch is a battery and a bulb. Well, isn't it lucky to have both a battery and a bulb? The current, a current, is 0.08 amps. Calculate the amount of charge, quantity of charge, Q in coulombs, passing a point in the circuit in 2 minutes. Time is equal to 2 minutes. But, of course, we don't like minutes, do we? Death on you. It's asking me for coulombs. It's not asking me for coulombs per minute or anything like that. So we're going to change that by multiplying by 60 into seconds, 120 seconds. Q is equal to I times T. That is not a multiply sign. Okay, that now is. Q is equal to 0.08 times 120. 0.08 times 120. All right, my handwriting is going to get a little bit bad here because I am not a Minecrafter or a codder, and my hand's cramping from using this mouse. In 1 second, an engine has a total energy input of 7,500 joules. In 1 second, 3,200 joules is transferred to the surroundings as wasted energy. Calculate the useful energy transferred by the engine. Well, the total amount of energy will be equal to the useful added to the waste. If we have got 7,500 joules of total energy going in, and I don't know this number, and I do know this number, then I can figure that out. Quite simply, 7,500 take away 3,200, 0.034, 4,300 joules of useful energy transferred. It now asks me to find the efficiency. So efficiency is measured in, I don't know, either percentages or as a decimal. So I'll just leave that as it is. The useful energy is 4,300 joules, and the total energy is 7,500 joules. You're going to get a question on efficiency. You might as well get used to it. Efficiency is therefore 4,300 divided by 7,500, giving me the answer of 4,300 divided by 7,500. 0.57333333333333333333. Don't worry about it. It is not your computer going on the fritz. It is just because we have a 3 recurring. Now I see this quite a lot of the time, but let's face it, who cares? It's a thousandth of an efficiency point. 0.57 is absolutely fine. Nobody cares about you. Ooh, oops. Just moved F. Ooh. Okay, now. Okay, and now my whiteboard is broken. Oh, no, it's not. It's just taking its time. A student uses a solar-powered battery charger to charge some batteries. That's very environmentally conscious. Well done, that person. The diagram shows how much energy is usefully transferred by the battery charger. Now, that's about as fuzzy as a frosty, misty morning. So let's have a look. 400 joules of energy supplied. So this is going to be my total energy. 50 joules of useful energy. Yes, good. Wasted energy comes out the bottom, just like all the waste out of our bodies. Ha 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 ha. And the wasted energy there is, I do not know. Calculate the amount of wasted energy. Well, just like the last time we said that total will equal the useful take away the wastes, which means it will be 400 joules is equal to 50 useful. Apparently, I keep on making a mess of this one. It's useful plus the waste. 50 plus the I don't know how many joules of energy that are here in my wasted energy. Useful plus waste equals total. So I'll do 400 take away 50. Giving me 350 joules as my waste energy transferred, 350 joules. I'm even going to put in the unit. I doubt you get full marks if you didn't put in the unit. Remember the units. Calculate the efficiency of the battery charger. Well, the efficiency is, I don't know. It'll be measured in either percentages or as a decimal point. Here, it's left up to me, so it can be neither. Useful is equal to 50 joules. Total is equal to 400 joules. Efficiency is equal to useful divided by total. Efficiency is equal to 50 over 400, giving me 1/8, which is 0.125 efficiency. If I want to do, I can multiply that by 100 to give it as a percentage of 12.5%. Oh, you're doing it again. Stop it. Stop it. Just no. I don't know what I'm touching. If anybody out there knows what I'm doing wrong, please let me know. you know, all three of you who are listening. Okay, looks like we got another efficiency question. Oh, stop it. Just the blades of a fan are turned by an electric motor. Excellent. In 1 second, the motor gets 200 joules of electrical energy from the main supply. So that to me looks like the total amount of energy. Only 180 joules of this is used to turn the blades of the fan. Well, it's all I want, isn't it? There's useful energy to turn the blades of the fan, so that is useful. And that is wasted. Calculate how much of the 200 joules of energy is wasted. The total, I'm going to get it right this time, is equal to the waste plus the useful. So the total amount of energy that's going in is 200 is equal to the waste, which is I do not know how many joules, plus the useful energy, which is 180 joules. Oh, I forgot my units. So the 200 take away 180, which is 20. Here we go, 0200, 20 joules. Calculate the efficiency of the motor. Well, efficiency is either in a percentage or it is in a decimal point. Over here, it's not saying anything, so I can do either one. Useful is equal to 180 joules. Total is equal to 200 joules. So if efficiency is useful divided by total, then I'm going to do 180 divided by 200, giving me 0.9. Efficiency, whoopsie, is equal to 180 divided by 200. Efficiency is 0.9. If I wanted to, I can multiply it by 100 to get that as a percentage. 90%, not bad. Very good. Is that right? Use turn the rest of the engine wasted, yes. A car engine produces an average driving force of 12,000 newtons. F is equal to 12,000 newton. Whoa. Okay. F is equal to 12,000 newtons. 1,200 newtons. Okay, so this question isn't going well. 1,200 newtons. The car travels a distance of 8 meters. Work done. By now we know that the work done is more energy. Energy equals I don't know how many joules. E is equal to F multiplied by D. E is equal to 1,200 times 8. E will be equal to 1,200 960. Yeah. 8 will be 9,600 joules. It just wants joules. It doesn't want anything funny. There's no extra things in the front. All is well. We can go on to the next question. And notice that even though I am, fairly bored, I'm still making sure I'm checking my work. Mass is equal to 1,400 kilograms and travels at a velocity of 25 meters per second. Velocity is 25 meters per second. Calculate the kinetic energy of the car. I mean, I wish by now they'd give us something interesting, hey? EK is equal to 1/2 times the mass times the velocity squared. EK is equal to 1/2 times 1,400 kilograms times 25 squared. I'm going to put that into my calculator. 0.5 times 1,400 times 25 squared. Oh, it's going to be a big one. 437,500 joules. I'm going to try to do this without making everything pause again. And I've only got 5 minutes before this file gets too big for me to store. So I might have to just stop this for a second. Oh, have I lost it again? I have not. Right, lovely. I'm going to stop this for a second because I just need to calm down my whiteboard. Yes, I want you to stop recording.